Hey everyone, how's it going? In this video, we're going to work through an example involving complex numbers. The problem says, if 1 plus 2i is a root of the equation z squared plus quantity p plus 5i times z plus q times quantity z minus I equals 0, find the values of p and q in the other root. So let me rewrite the problem we're dealing with here. We have z squared plus quantity p plus 5i times z plus q times z minus I equals 0. Okay, so what does it mean to be the root of the equation? Well, when you're the root of an equation, that means when you plug that number into the equation, you end up with 0 as your final answer. So that's exactly what I'm going to do. I'm going to take this root of 1 plus 2i, and I'm going to plug it in for z right here. So what's that going to give me? That's going to give me 1 plus 2i squared plus p plus 5i times 1 plus 2i plus q times 1 plus 2i minus I equals 0. Okay, now I'm going to expand a few things. So 1 plus 2i squared becomes 1 plus 2i times 1 plus 2i plus p plus 5i times 1 plus 2i plus q times 1 plus, now 2i minus I is just I equals 0. Okay, so now I'm going to start foiling some things. So 1 times 1 gives me 1, 2i plus 2i gives me plus 4i, 2i times 2i gives me plus 4i squared, plus p times 1 is p, 5i plus 2pi, so those you can't add directly, so I'm just going to write plus 5i plus 2pi, and now 5i times 2i gives me plus 10i squared plus q plus qi equals 0. Okay, now what is I squared? Well, I is equal to the square root of -1. So then I squared is equal to the square root of -1 times square root of -1, which is equal to -1. So everywhere where we have an I squared, like over there and over there, I'm going to rewrite that as -1. So that's going to give me 1 plus 4i. Now 4 times -1 is -4. Plus p plus 5i plus 2pi minus 10 now plus q plus qi equals 0. Okay, now if we look at our final answer, it equals 0, right? So what does this mean? This means that we don't have a complex part of our answer or a real part of our answer left, which means that all of the real parts of our answer have to add up to 0, and all of the complex parts of our answer have to add up to 0. So what I can do is I can pull these out individually, and I can set them out equal to 0. So I'm going to take all of my real parts, which is going to be 1, -4, p, -10, and q, and I'm going to set them equal to 0. So this is going to give me 1 minus 4 plus p minus 10 plus q equals 0. So 1 minus 4 minus 10, that's going to be -13. So -13 plus p plus q equals 0. And I can say p plus q is equal to 13. Now I'm going to do the same thing with my complex parts. So I'm going to have 4i plus 5i plus 2pi plus qi equals 0. Now 4i plus 5i gives us 9i plus 2pi plus qi equals 0. And I can divide I on both sides, so I can get 2p plus q is equal to -9. Now, if I take both of these and I see that they're a system of equations, I can subtract the bottom one from the top one. So p minus 2p gives us negative p, q minus q is 0, equals 13 minus -9 becomes positive 22. And what is it simplified to? Well, this becomes p equals negative 22. So now to find what q is equal to, I can just take this p equals negative 22 and plug it into, say, this upper equation right here. So negative 22, I can write negative 22 plus q equals 13. And then if I add 22 to both sides, I get q is equal to positive 35. So here we just found our values for p and q. Now the second part of the problem wants us to find what the value of the other root is. So we just found that p is equal to negative 22 and q is equal to 35. So I'm going to plug those into the original equation. So that's going to give me z squared plus, now it's going to be negative 22 plus 5i times z plus 35 times z minus I equals 0. Okay. So now, what type of equation does this look like? Well, it looks like it's almost a quadratic, right? We have a z squared, a z, and if this z wasn't here, we would just have a constant, right? So let's expand what we have. I can write z squared plus negative 22z plus 5iz plus 35z minus 35i equals 0. I can combine all the like terms here now. So I'm going to have z squared. Now negative 22z plus 35z gives me plus 13z plus 5iz minus 35i equals 0. Okay, great. Now I'm going to factor the z out of both of these. It's going to give me z squared plus 13 plus 5i quantity times z minus 35i equals 0. So now we have it entirely in quadratic form. We have z squared, z, and no z. Now, we already know one of the factors, right? One of the factors, or roots, is 1 plus 2i. So, to find the second one, there's a few rules we can utilize. The first one says that the sum of the roots equals minus b over a. And the second one says that the product of roots equals c over a. So now let's figure out what our b, a, and c terms are. Well, this is going to be our a, this is going to be our b, and this is going to be our c. Okay, so let's try to figure it out both ways. We know that the sum of our roots is going to be negative b over a. So what's negative b over a? Well, b over a is just going to be equal to b because a is 1. So now negative b becomes negative 13 minus 5i equals our first root, 1 plus 2i, plus our second root, which I'll just call r. So now I'm going to solve for r. I'm going to do minus 1 minus 2i from both sides. And I'm going to get r equals negative 14 minus 7i. So this is our second root. But let's also try to solve it using this product form. So to solve for this using the product method, we take our c over a value. So a is once again 1, so we can just take our c value, which is negative 35i, and set that equal to the product of our roots. So our one root is 1 plus 2i, and our second root is unknown. So you can divide both sides by 1 plus 2i, and that is going to give us r equals negative 35i over 1 plus 2i. Now, when we're dividing by a complex number, we can multiply by the conjugate. So I'm going to multiply by 1 minus 2i. And let's figure out what that equals. Well, negative 35i times 1 minus 2i, I'm going to distribute that. That's going to give me negative 35i. Negative 35 times negative 2 is going to give me plus 70. And I times I gives me I squared over 1 times 1 is 1. 2i minus 2i cancels out. And then 2i times negative 2i becomes minus 4i squared. Okay. On the previous page, what did we say that I squared equals? Well, I squared just equals negative 1. So this actually equals negative 35i minus 70 over 1 plus 4. And what does this simplify to? Well, it becomes negative 35i minus 70 over 5. What do we get when we divide that out? Well, we get negative 7i minus 14, which is actually what we got using the sum method. On the sum method, we got negative 14 minus 7i, and these are the same thing with just their orders switched around. So, as you can see, either method works, and they both give you the same answer. If you found this video helpful, please take a second to hit the like button or comment down below. If anything in this video was unclear, or if you had a question about any other topic, please don't hesitate to comment it or send it to me in a message, and I'll do my best to answer it for you. Thanks for your support, and happy studying.